You know, we all use software that just feels solid. It's powerful, it's fast. And then we've all used those other apps, the ones that feel like they're held together with duct tape. Well, the difference isn't magic, it's architecture. It's that secret plan, that blueprint, that makes all the difference. I mean, have you ever really thought about that? Why can your banking app handle millions of people at once without breaking a sweat, but some other app crashes if you just look at it the wrong way? Well, the secret? It's not on the surface. It's all about how the data is organized underneath. And that right there, that's the big idea for this whole thing. Building a powerful database is exactly like building a skyscraper. You don't just, show up with a truck full of steel and start welding things together. Nope. You start with a detailed blueprint, a master plan that guides every single decision you make. So to really get this blueprint idea, we've got to look at the master plan first. Just like any big construction project, building software follows a really structured process called a life cycle. And it turns out there are actually two of them we need to care about. Okay, so first up, you've got the big picture, the Systems Development Life Cycle, or SDLC for short. This is the playbook for pretty much any software project. You start with planning, figuring out what you're even building. Then you've got analysis, design, the actual coding, which is implementation, and of course, maintenance, because you got to keep the lights on. But here's where it gets really interesting. Tucked inside that big overall project, the database has its very own, more detailed lifecycle, the DBLC. And that's because its whole job, its only job, is to protect the data. The bottom line is that good design is a process, a series of steps, not just a one-time thing, right? I mean, an architect can't just start drawing a house without knowing if the client wants 2 bedrooms or 5, or if they need a big kitchen. For a data architect, that same conversation is all about uncovering something we call business rules. So what exactly are these business rules? Think of them as the laws of physics for that company. They're the non-negotiable truths that describe how things work. And you don't just make these up. You get them by talking to everyone, from the folks in charge to the people who will actually use the system every day. Here's a perfect real-world example. This simple sentence is a business rule. See, that's not a friendly suggestion. It's a hard and fast constraint. When we go to build our database, we have to design it so that it's literally impossible for the system to schedule a pilot for more than 10 hours. The business rule forces the design to behave a certain way. All right, so we've got our rules. Now the architect can finally start drawing. And this isn't just one step. It's a 3-phase journey that takes us from a fuzzy idea to a database that's, well, built like a tank. So let's jump into phase 1. First up is what we call the conceptual design. I absolutely love this part because it's basically a sketch on a napkin. At this stage, we're not thinking about what software to use or what servers we need. Nope. We're just figuring out the big pieces of the puzzle, the main things we need to keep track of, like a person or a passport, and how they're connected. And this is what you get from that first phase. It's called an entity relationship diagram, or ERD for short. This is our architect's very first sketch. You can see the main things, the entities, in boxes, person and passport. And the verb connecting them, has, is in the diamond. It's super simple, it's visual, and anyone can look at it and get what's going on. Okay, phase 2, the logical design. This is where we take that simple napkin sketch and turn it into a real, formal blueprint. We're translating those big ideas into a more detailed structure of tables and columns. Now, get this. We're still not choosing a specific brand like Oracle or MySQL, but we are mapping everything out in a way a computer can understand. See the change? It's a big leap, right? That simple sketch we had, it's evolved into this. Now, person isn't just a box, it's a table with specific columns for things like a person ID and a first name. This is the real blueprint. It's got enough detail that an engineer can look at it and know exactly what needs to be built. And that brings us to the final step, the physical design. Okay, now we're getting into the really nitty-gritty technical stuff. This is the architect on the construction site, pointing out exactly what kind of steel to use, where the pipes go, and how to make the foundation as strong as possible. We figure out exactly how the data will live on hard drives, how we'll keep it safe, and how we'll make it lightning fast. And boom, here it is, the final output. I know, it looks super complex, right? And well, it is. But the key is, because we did all that careful work in the first 2 phases, this complex system is actually built on a really simple, solid foundation. This is the plan you can actually build. Of course, a blueprint is totally useless if you don't know how to read it. So let's do a super quick crash course on the language of a data architect. It's way easier than you think. It really just boils down to three main things. First, you have an entity. That's just a fancy word for a noun, a thing, like a student. Then you've got an attribute. That's just a detail about the entity, like the student's name. And finally, the relationship. That's the verb that connects them. A student enrolls in a class. See? Nouns, details, and verbs. That's the whole game. Now, where it gets a little fun is that these relationships come in a couple of flavors. Up top, you see a really simple one, one-to-many. One professor can teach many classes. Makes sense, right? But down below, we've got the trickier one, many-to-many. Many students can enroll in many different classes. And this one causes headaches for new designers. So that many-to-many thing, it's like a classic riddle every data architect has to solve. You see, you're not actually allowed to connect two tables like that directly in a relational database. But don't worry, there's a really clever, elegant solution. Just think about it for a second. How do you connect many students to many classes? If you've got one student taking 5 classes and one class has 30 students, how on earth do you track who is in what without it turning into a total spaghetti mess? And here's the magic trick. It's so cool. On the left, that's the mess we're trying to avoid. The direct link that's just not allowed. So on the right, look what we do. We put a brand new table right in the middle, a go-between, we'll call it enrollments. It's like a bridge connecting the two. And every single entry in that bridge table does one simple thing. It links one specific student to one specific class. Problem solved. So at the end of the day, that's really what it all comes down to. If you just jump in and start coding without a plan, you're building a data shack. Yeah, it might stand up for a bit, but it's not going to last. But if you take the time to go through the process, get the rules, sketch it out, make the blueprint, then build, that's how you get a data skyscraper, strong, scalable, and built for the long haul. So the next time you're using an app and it's just smooth, it just works, pause for a second. Think about that invisible architecture humming away underneath it all. What's the unseen blueprint that's holding your digital world together?